like a bull in the china shop. Okay, welcome to week 4. This is lecture 7, and we're flying along. Okay, so this is a third of the module completed already. You have an assignment that started today, or no, yesterday. Did you see the assignment? Yeah. It's a nice assignment, you know, and it's meant to give you that extra bit of expansion on some of your web development stuff, to have you thinking about SVGs. Okay, and I wanted you to come to grips with basic SVG commands for drawing and visualization, because it's good to know, you know, and we didn't really get to do that last year in CS230 for one. Second of all is that the final examination, the coding exam last year, was based around generating emoticons using SVGs, okay? And it was kind of an emoticon generator. And it worked well. I mean, students did really well in this. And the basic idea was to be able to design a piece of software rather than just write a piece of software, okay? And so, for example, if you want to create and think about the kinds of activities that you perform when you're generating and producing an image, you know, you will have create, undo, add a shape, undo. And so there's this whole method of interacting with software that allows you to be able to work with you know, real world activities, you know, doing something, changing it, and so forth. And one of the key design pattern approaches that we'll be looking at later are alternatives to being able to do this do and undo. And we'll be looking at something like the memento, the design pattern, and so forth. How do you do this? What's the best way to manage all that? Do you, for example, when you're making an image, do you just have a stack, and every time you add something, you push something on the stack and take it off the stack? Yeah. Or if, for example, you would have, or do you look at the changes? Like, so for example, if you're changing your code and you're saving something to GitHub, then do you just save the whole file every time it changes, and then when you want to revert, you go back to the stack of changes? Or do you record the individual changes that you make and just save the individual changes, or the deltas? Yeah, essentially, deltas are small changes. So there are different ways of approaching and thinking about how you might do that kind of thing. And when you want to embed this into a piece of software yourself, you have to look at the alternatives for design. So if you're building something, like building an emoticon, or building a pizza, or building a house, or a car, or something, and you want to do this virtually, there are builder patterns. So there are all these kind of design patterns that you would use and build. So the idea was to get you thinking about this, how you might do it with graphics early on, and then later, when it comes to the exam, you're fairly competent. It didn't work out 100% well, because I think students had to do an awful lot of extra work on their own with dealing with SVGs, you know, and you know, I forget sometimes that I not that what I teach, but I always assume that students, when they're not doing my course or not doing the other courses, they're still doing computer science in their own time, and that they have no life, you know, and that all they do is think about computer science, right? You know, that's when I was a student, I did physics, and you know, if you're a physicist, all you do is think about physics, day in, day night. You look at the world around you in terms of physics. So you're not all like me, thankfully, and so this year I decided that I'd make a slight change. So I still have a similar assignment like I had last time, but I'm going to just break out of this for a second and show you a couple of small things that will help with the assignment. So for example, I produced this document over the last few weeks for you on how to work with scalable vector images. And it's a markdown file which I'll upload for you to be able to play with. And it actually essentially provides a lot of the background stuff for how you would do some SVG programming, all the basic commands, and then how you might create a basic emoticon, for example, using an SVG. Okay, so that uses all the various commands. I'm giving all the code. These are Kamoji, rather than emoji, the Japanese version of confused emoji. And then I show you how to build the Western version of a confused emoji as well, with the various arcs and paths and so forth. All the various commands are there. And then these are how they would look like if you're using a phone, how you might use scaling and filters if you want to do that kind of stuff. And then I show you how you could actually control animation using the facial animation using this JavaScript. So it ties in with the stuff from last year. Okay, you don't need to do all this kind of stuff. Okay, but you know how you might switch, change colors, and so forth. So I might do a quick talk through on this, and it'll give you some background on how to do SVGs. Okay, so it's kind of, it'll save you doing loads and loads of searches. All the basic commands are here. Okay, and it should help you with that assignment. Is that fair enough? Yeah. So it's a bit of a background work for you, 15, 20 minutes, and it will be fine. I'm also because this is EU Coding Week. Next week, I'm giving a kind of a 1.5 hour workshop on how to generate and do animation and so forth with SVGs. Okay, from 11 o'clock until 12:30. It's a live stream to YouTube. It's mostly for school kids, you know, and to introduce them to things like little ghost type stuff down the corner, how you can build little ghost characters and animate them and do stuff. And I mean, if anybody's been to McDonald's recently, you'll see this little guy in the corner on their screens. I spotted it as I was walking past and looking. I thought that's easy to do, so I built all those with SVGs and built some little animations as well. Okay, so SVGs are really powerful, really cool, and fun stuff. And you know, it's a good thing to know. And if you're anyway creative, it's a nice way to be able to do this. And you can generate all these with C#. You can generate it with JavaScript, manipulate and control them, and you can do all sorts of fun stuff and make a nice portfolio piece that you can have when you go for applying for interviews. Remember, you know, your marks and so forth, and your course you're doing will get you into the interview. It's what distinguishes and differentiates yourself from the other students. The things that you do, your portfolio, your fun stuff, that's what actually gets you the job, okay? After you get the interview. So try to look at some of that stuff. So, you know, the live stream will be available. I know you guys probably have classes, but the live stream will be available afterwards, and you can look at it if you want to learn more about that stuff. But I'll put the files up anyway for you, okay? And you can have a peek. So you should be able to have lots of background that will help you with the basics of the assignment. Now, it doesn't take away from the fact you still have to understand your C# code and build a user interface and interactive and all that kind of stuff. But bear in mind that I'll come back to this a little bit later. There'll be a similar assignment to the final coding exam like I had last year. There'll be a different approach to it this year. Okay? You know, big hint. Look at the little ghost that was in the corner. Might be something around those kind of things, okay? You know, and we'll see. But, you know, I don't have any surprises, as you know from taking my courses previously. There are no surprises. I tell you exactly what's coming up in the exam, and you just have to do it, okay? It's just how well you actually do it. No surprises. I don't like surprise students and stuff, okay? Okay, so let's move on from now, and we're going to look at some advanced concepts. Now, this is really so that you come to grips with C# and learn a little bit more about doing stuff with C#. Because if you want to work professionally or want to work in and apply for you know, positions around C#, you're going to need to know how to do some of this stuff. Okay, you don't need to do all of this in order to be able to do a lot of the design patterns. Okay, some of these are features of C# that aren't available in Java or some other object-oriented languages. Okay? But it's worth knowing about them. You know, it's worth knowing about this perspective. And when you think about programming, in general, we're only interested in two things. And it's quite simple, quite straightforward. And I know somebody mailed me recently and said, you know, we have to learn a new language, and it's hard. And of course it's hard. It's always hard. But I always say, don't forget what you know already as third years, you know, third year students. You need to remember that we have data, and we process those data. That's it, right? So the fundamental ways in which we process data are, you know, will change and over time, but there are some fundamental ways that we do deal with this. And then there are ways in which we organize data. We might organize data as nice, neat little tables, or we might organize it as collections of data, okay, which are not so neat. Objects, collections of objects. And the main point to remember is that there's this intimate relationship between data and how you process those data. Okay? So in other words, what something is and how you interact or engage with it. And this is really important that you understand it at this conceptual level. Okay? So sometimes you can look at the world and you can have a very simple model of what's happening in the world. That means you have to actually work a lot harder with the code in order to be able to manipulate that world, okay? And the more code you have, the more chances you have for making errors. Okay? More code, more errors. More testing needs to be done and so forth. If you have a more complex representation of that data in terms of how it is, sometimes the actual coding to be able to engage with it can be a lot simpler. Fewer lines of code, fewer errors. Of course, your representation may not be as accurate as you would like it to be. So most programs that you will write involve you, and design will hinge on design. That means that you're going to have to think about your representation of the world and all of the options that you have in the various programming language that you're using to help you represent the data. And then when you have that representation, a lot of the time that will then determine how you engage with that data and how you write software that works with that. So I want you to think about that and remember this. So you can probably do almost everything with just simple arrays, you know? You can do loads of things with just a simple list. Linked lists, my favorite data structure in the whole world, okay? You know, I mean, I always have this, no chalk, so I can't write on the board, I think. Maybe there's chalk, but never chalk when you want it, you know? The good old-fashioned chalkboards used to have a little holder where you could put some chalk. But anyway, but my favorite programming language is Perl, and everything is a list in this, you know? And so you can model most things with lists. Objects are the next thing up, and classes, all that kind of stuff. So the stuff that we're going to look at today is really another way of providing you with ways to represent data and to manipulate those data in ways that minimize and reduce the code that you will write, and ultimately reduce the kind of errors around this code. Okay? And not just the syntactic errors, we're talking about semantic errors. You know, and you remember back to first year, semantics were errors of meaning, where the code runs, doesn't give an error, but it doesn't run the way you expect it to be, to do, okay? Those are the worst kind of things, all right? So a lot of that can be controlled using good design. Okay. So we'll look then at some features of C#. So we're going to look at some of the stuff that you will need to look at in the future, and they will be indexers, collections, generics, and link. That's this week. We won't go through all of these in this particular lecture, but the next lecture, which is the online lecture, the 5 sessions, the 5 short lessons, they each address some of these. And all of the code, of course, will be available for you to take and play with. Okay. And I want you to play with it. Don't just download it, you know, play with it. Some of them have errors, by the way, mistakes. And every so often I get a student who actually does take it and play with it and say, John, that program didn't work. You know, I know that person has actually played with it, you know. But or made some changes. So please try this. You know, it's a good way to learn to code. And you know, these should be working programs mostly. And if they aren't, I probably have a comment in there to tell you why it's not working. You just have to read it, you know. But that's me playing with you as students, okay, and learners. So what's an indexer then? An indexer allows an object to be indexed like an array. Okay? Because we know arrays and we know it's nice, because a lot of the time we have collections of stuff and we want to be able to say, give me the 5th item in this collection. Or just, you know, we want to specifically name an item. So how do you index and organize collections? So indexers are really good for that. So you can define an indexer for a class, then the class actually behaves like a virtual array. It isn't an array, but it behaves like one. And you see, behaviors are really important. And a lot of these advanced features allow you to attribute behaviors to something that wouldn't normally be the way they are, okay? Yeah? And that's really, really important, okay? That means that when you access instances of the class, then using this double bracket operator, and we know how they behave. That's nice. So if we have all sorts of algorithms then that work on arrays, or searching arrays, or manipulating, or doing something to arrays, or swapping, and so forth, we can actually use all that knowledge that we've learned already. Techniques. So the reusable, simple techniques are good because we've actually organized our data in a way that it becomes amenable to the processing that we know and love. Okay, so collection classes then, they're specialized classes for managing data storage and retrieval. And the reason you do all your data structures course in second year is so that you can understand what these data structures are and how they work, and you have to learn how to build them. But once you've done that once, you don't have to do it every time. You just use a library, you use a built-in function that says, well, I'm looking at this data here that I have to manipulate, and I think, yeah, that could be represented as a list, or could be represented as a hash table, or it could be a queue, a list, a bit array, okay? All of these things. And these data these data structures are called collections, and there are classes, and they're actually extensions of the object class, which is the base type class in C#, and they're available for those, and they're there. You don't have to rewrite or work any of these things, so use them. Okay? Make life easy for you. I always say, you know, I'm because as I mentioned already, I'm a huge fan of Perl programming language, and it was written by somebody called Larry Wall. The beautiful book worth reading called Programming Perl, and he talks about, you know, what it takes to be a programmer, and one of them is essentially laziness, you know, and hubris and so forth, you know. So it's about being virtuously lazy, okay, you know. You can take it right to the extreme and write code that people can't understand, of course, by reducing everything. But the basic idea here is that reuse what's there, okay? Nothing wrong with that. And again, as I said to you in assignments, if I give you code in lectures, reuse that code. I just say I'm using this code. If it's something that's on the Microsoft website, you know, the tutorial sites, reuse some of those things. Say I'm using those. This is kind of general knowledge, you know, reuse that stuff. You know, I try to ask you to do something that isn't available in the public domain. So that's pulling all these things together. And that's a good thing to do now. This is about design. Okay. The other thing are called generics, and they are really interesting because they facilitate the deferred definition of the specification of classes and methods of one or more types until the class or method is fully declared and instantiated by client code. So that allows us to develop a class or a method that can work with any data type. In other words, I have these class of objects that I know I'm going to need to manipulate. Okay, I want to sort them. I have a good sorting algorithm, and as long as I know how to compare one of those items with the other, I can actually write a generic sort or generic piece of code that manipulates those. So I reuse a lot of this generic code and I only have to write the piece of code which may say, how do I compare this object with this object? Because a lot of the time when we're working with objects, it's about sorting or searching and so on. Okay? So these are the top items. But we'll start with the basics ones. And you did a lot of work with your basic arrays last time with your assignment. But don't forget about arrays. Arrays are really useful, and you can see how powerful they can be. But they are structures that store fixed numbers of literal values. Okay? And in C#, they can be single dimensional, multi-dimensional, or jagged, as you've seen here. Okay? And you saw these before. You can see that we can create a basic array, which is using the square brackets. We can create numbers or strings, and we can also use var instead of int. So we can actually define the type later if we use var. Okay, we're just creating an instance of a variable, and the type will be automatically decided by the compiler for us. And so we're creating this new string of numbers, and here we have a new string. We've one called Brontes, which have the four sisters here as strings. And again, there's no size required at the declaration phase, as you can see already. Here's some primes. Again, here's some strings again, and you know we can have this late initialization if we wish as well. So there's all sorts of ways in which to do this, and then we can actually iterate over a fixed number. We know the fixed number, or we can just look at each element in the array. So you're essentially treating the array like a list and working from there. And as before, if you want, you can actually have a look at the code. We can look at the arrays, and my arrays, there's all sorts of examples there of how we might work with various arrays. So the example that I've given you, I have a lot more information here on creating matrices, creating jagged arrays, and you know, dealing with errors, and show how you can actually end up making errors. And sometimes you know, you might want to trap those errors as well. Okay, so it's worthwhile having a look at the sample code and working through this. So there's an example called arrays, and you can have a look and run this. Okay. Again, before, if you see demo, it will be there. Okay. So multi-dimensional arrays then, they're declared by adding commas inside the square brackets, and you've had to look at two-dimensional arrays, of course. You can declare three-dimensional arrays and jagged arrays instead of literal values, and I showed a little bit about that last time as an example. The first bracket specifies the size of the array, and the second bracket specifies the dimensions of the array that's going to be stored. It's fairly straightforward stuff, but you do need to be able to look and work with these. So here's a new type, okay? And a new type, we saw objects and object-oriented types last time when we know how to generate classes and objects in those classes, but we have this structs in C#, okay? And a structure type, or a struct type, that's a value type. And that can encapsulate data and related functionality. So you can use the struct keyword to define the structure type. So the structure types have what are called value semantics. That means that a variable of a structure type contains an instance of the type. Okay. There are values, okay, so it contains an instance of the type. Okay. So by default, the variable values are copied on assignment, passing an argument to a method and returning a method result. So in the case of a structure variable, an instance is always copied. Okay. So when do we use these? So typically you use structure types to design small data-centric types that provide little or no behavior. So when you think about, we talked about LAMP objects, LAMP, there's a single piece of data and a single method. But let's say you want to have lots of different kinds of data, but you don't do much with them. There are not lots of methods. So they're highly data-centered rather than procedural-centered or functional. So instead of creating objects and classes and all that kind of stuff, we just create the struct because we're mostly really interested in just anything to do with the data itself. So if you're focused on the behavior, you should define a class. But if you are mostly working with structural data, or data in itself, or things that don't do much, then define them as structs and make them immutable. Okay, that's just a way to engage with it. So it's nice. So in computer science, we really need to focus on value semantics. And in computer science then, having value semantics, and it's sometimes called value type semantics or copy by value semantics, that means for an object that only its value counts, not its identity. Okay, it's an important concept that you understand. Okay? Have you come across this in other courses about this at all? No? Yes? No? Compilers, any of that stuff? No? Okay. It's just something to think about, It's quite philosophical in a way, okay? So it means that we only the value counts, not the identity. So if the concept is fully applied, value semantics implies immutability for that object then. So an immutable object is defined as an object that can't be changed after it's been created. So it essentially allows us to combine lots of attributes as a single item, and then we can index essentially that item if we want. Okay, get the parts of that item. So sometimes this stuff can be a little bit hard. I'll try to reduce it just to this one lecture, okay? But you can revisit, of course. Okay, so let's look at some structure types then. So we use the read-only keyword to make a struct immutable. So for example, a point, right? So if we create a point in space for graphics applications, then point doesn't do anything. It just exists in space, okay? Does that make sense? Yeah? So why would you, in the past, you may have created classes and objects and all this kind of stuff. Now you might want to move the point, whatever, but like it's still, that point in space is data-centered. So it just exists as a point. And a point, essentially, it has two parts, and we want to be able to pull out the x value and the y value, or the x, y, and z value, or all of the n dimensions if you declare a point in n-dimensional space. Okay. And that's all we want to be able to do, and we want to be able to do something with this. Okay. So the struct method is really useful in that particular, in this regard. So we don't have to waste time in creating all sorts of classes and extending classes and all that kind of stuff. Just create a struct. Okay. So structs can include constructors, constants, fields, methods, properties, indexes, operators, events, and nested types, but it can't include a parameterless constructor or a destructor. Okay. You come across destructors before? No, because you did Java, and Java doesn't allow you to work with destructors. because these structures are what you use to destroy an object or a class or all the information that you have in memory, and you don't have that level of access to memory management or garbage collection when you do Java. The Java virtual machine handles all that stuff automatically for you. You come across this when you do your compiler course. So really what's happening here is that you don't have these. We can have them, but we don't use them here. So it's useful to know. Parameterless constructors aren't allowed. Struct can implement interfaces. They can't inherit another structure or class, and it cannot be the base of a class. And struct members cannot be specified as abstract, sealed, virtual, or protected. They just exist as they are. Okay? So here, for example, is a point where we're creating this public struct point, and we have a constructor and allows us to be able to create a point. Okay? Okay. Okay. And it's not parameterless. Okay. It has to have parameters. You have to pass some data into the struct in order for it to be able to get held inside the struct and be able to do something with it. Okay? We just can't have a constructor that doesn't have parameters. Okay? If you try to do this, it will give you a fault. Okay? Let's look at see what happens if you have this set the origin. So you change the value here. Okay? You can try to play and see, well, what happens when I do this. So the code will be there for you to play with. I hope. My structs. Okay, so we click here. And we can run this and play with this. And I've done, again, as you can see, I have done lots of extra stuff in here that works with this struct that isn't available on the slide. So please go to the demos and have a look and play with the demo. Okay? Give you a little bit more information. Okay? We might run some of those again in a few minutes. Okay? So it's really useful. Okay? You'll notice here that I have this expression body definition here. I'm creating this toString method. And I'm overriding the method that would normally be associated with a struct or with an object or something, because everything is inherited from objects all the time anyway, and there would be a string method, and we're actually overwriting this method. So you could actually then convert something to a string, and this tells me what the string will look like. In other words, I'm going to take the data, and when I print the actual object in a console.write line, as a point, I wanted to write it as a point. So two values separated by comma with brackets on it. Okay? I don't want to be doing that every time. I don't want to be pulling out all the various bits, the various components, and then writing these things. I just want to build a method that overrides this, and so when I just write it, this method gets called, and then I write it to display. Yeah? So you can do that by overriding a method. And this is how you do it. Override. Any questions? Yes?
So would that mean that you're taking the toString method and telling it, instead of putting it the normal way, put it in this specific format?
Yes. So we don't know what the normal way is for printing this yet, okay? I mean, the only way to do it is actually to take this point, not have the method, write this thing, write it, the instance of that point, and then see what happens. And then say, I don't like that. I want it to actually look like point. Okay? And you could do this. Okay? Is that fair enough? Yeah, good question. Okay. Anybody else? Yes? Yeah, the lambda expression operator. Yeah, good question. And this is an expression body definition. It isn't actually a lambda expression. It looks like one just because it has the lambda operator. I'm going to come to that on slide 10, okay, if that's okay, because it can be a bit confusing, and it's basically a shorthand notation, which allows us to be able to, in this case, shorthand notation generates some code, sometimes it's to actually do some other things. So I'm going to talk about that again. Good question and well noticed, and a lot of time people will use, and I've used it a couple of times. I think I used it in one of the slides last week. People didn't ask any questions. You may have seen it in some of the demos as well, but it's really, really important in C#, and you see a lot, and I will explain a little bit there. Okay, is that okay? Great, thanks. Anybody else? Okay, good questions. Okay, so, well, let's have a look. Let's run this one, actually. Let's do some fun stuff here. So this is in my structs. Right, let's open the terminal. Okay, cd. I'm running the program without was actually looking at what's going on. That's what people tend, because that's what people tend to do when they download code and go, oh look, it works, and then leave it there. Okay. The thing to do, of course, is to be able to look at inside the code. Okay, so we have a program which is in its namespace for my structs, and we have this struct point rather than creating a class point. Okay, and the reason we're using a struct instead of using a class is because it doesn't do much behaviorally. It just exists as data, and that's why we use structs. Yeah, so it's a good thing to do. We have a constructor here. We have to have a constructor that, let's put in another constructor, because we know we can overload constructors generally. Yeah, so let's have a look at that. So we would often do this kind of thing. So here's another constructor for the point. Yeah, can you see how I've done there? Yeah, I just created it. Now let's run it. Lots of red. You know, I love seeing red when I expect to see red. Okay, I don't like seeing red when I don't expect it. Right? You know, so when I make an error and I know I'm making an error, and then I get the error, I think, yes, I have some level of understanding of what's happening here. Let's see, does it help? Okay, actually, it says here, structs cannot contain explicit parameterless constructors. And we know that because that's the rules, okay? So it's really good that the compiler actually knows what it's supposed to do, okay? So that's okay, so let's get rid of that line. So, and this is what I mean by playing with code. Okay? You know, see, do you understand? Make changes, get errors. You know, because later on, you know, sometimes you just get the error and you'll be able to think back and say, and read the error and say, oh yeah, that's what the error is. I go and I check for that. Error, don't be afraid of errors. They're there to help you. The compiler is your friend, okay? And that's really, really important. Okay, so let's have a look at what else we do. So I'm saying then that this point struct has two variables, capital X and capital Y, okay? And so let's have a look. We're overriding this string, okay? Let's get rid of this and see what happens when we print the point without our overriding our method, yeah? Makes sense. Okay, so this is what we get, okay? My structs.program point, okay? All it does is tell me that information. Okay? That's what printing or writing to the console string, because that's the default string method that's associated with the object class. It just tells you something about what the object is, yeah? Some level of internal reflection that says, what am I? Well, I'm a point. So I'm just, when they ask me to print, I'm going to say, I'm a point, okay? Struct. But what we really want to be able to do is to say, give me the information about that. So we override the string method so it works. Does that seem fair enough? Can you see the difference there? Yeah. So you could do this with all of your classes and objects. Rather than having to write methods to call various parameters and all this kind of, just have a toString, override it, and then say, well, this is a kind of a summary version of what I am. Okay? The string representation. I mean, we can change this. Okay, let's do this. So let's instead of the comma, let's do this. Okay, so let's say imagine this is how we represented points. Okay, with square brackets and a dash. And now my representation is this. Why? Because I told it that's what to look like. Okay, so you could do this for any of your objects, any of your structs, any of that stuff. You can override the string method and make it work. Makes life very, very easy for you. Okay? Any questions? Okay, we move on. So structs are great, useful for data. So we now know that there's a way to structure an individual data item as an alternative to the object in the class format that we would have had. We know arrays are cool. We know arrays are nice and structured, easy. It gives us a nice view. Sometimes that view on the world isn't rectangular or square, but we can have jaggies. You know, we can do that if we want. So what we might want to do is, but we'd still like the fact that we can index arrays. That's what we really like about indexes, because we can use loops to iterate, and we can do this nice iteration over the collection. Okay. So C# allows us to generate something called an indexer, and that allows an object to be indexed like an array. And Microsoft refers to these indexers as a syntactic convenience. Okay, it allows you to be able to create a class, a struct, or an interface that you can actually access as an array. That's beautiful stuff. Okay, means the code can be simple a lot of the time. Like I told you at the beginning, the more complexity you have and functionality you have around your organization of data, often the processing of those data then becomes easy. So indexes are most formally implemented in types whose primary purpose is to encapsulate some internal collection or array, like a record of grade scores for different assignments in a module, for example, something close to your heart, of course. So for example, say the class grades record contains a grade array of type float to store the grades value. Then we can actually have an indexer on that class, and we can access the record information using this dot notations in addition to the index on the object. Okay? So it's fairly straightforward. If you have an indexer on a class or struct, you must use the this keyword as well. Okay, it's just sometimes people forget that. It's useful to do. And again, I have an example. I'm not going to have time to go through all the example, but you can just check the indexers. Again, if you look at the indexers and have a look at the program, you can see that I have a lot of example of how to work through working with the indexers, all the various options, how it might work, how you can play with it, and please do. Okay, these programs are there for you to work with and learn something. Okay, so that's a useful way to be able to do this. Okay, and again, this time I've created a class grades record. I'm not using a struct here. I'm using a grades record as a class from which I generate objects, because it isn't just the data centric. There are things I want to be able to do with those grades, like calculate, get averages, all that kind of stuff. Okay? So that's why I'm using this instead of a struct this time. So here we have an index example again. If you want to look at that code, and coming back to this man's question, we'll come after this slide here about the expressions. So we make the this keywords in order to make the indexer, and the type of the indexer and the type of the parameters must be at least accessible to the indexer itself. That's really important as well, I guess. So here we have some index happening here, okay, and that's the indexer declaration. Okay, that allows us to be able to pull out the information from this particular internally in the structure. Okay, so if somebody is interested in using an indexer, this is how we work. Okay, so it's using this. You can see this. This refers to this object. Okay? Sometimes you often use it as this dot x, for example, to look at a parameter or something. Yeah. So this in itself with an index on it. So the signature of the indexer consists of the number and the types of its formal parameters. Okay, so here we have one parameter, which we're going to call index. You don't have to. You can call it bananas if you want. And its type is int. And if you declare more than one indexer in the same class, they must have different signatures. So we overload rather than override. Okay? Overload. Okay, so you have lots of indexers. So you can have different ways of indexing the same piece of data. Very nice and useful. An indexer value is not classified as a variable, so you can't pass an indexer value as a reference or out parameter. And C# allows us to define custom indexers, generic indexers, and they will work with enums and some structs as well. Okay, so have a look at the code. Okay, so what's interesting is we see this here. So I have this getter and setter property using this fat arrow notation that we looked at. Okay, as part of my definition. What's going on here? Okay, And when you look at code and you see something, try to figure out what's going on, okay? And you can do a C#. You can Google C# with this arrow, and there's lots and lots and lots of pages around it. Okay. But what's happening is that when we use this arrow, this fat arrow, or this lambda notation, there are two things normally going on. Okay, we're creating a lambda expression, or we're creating an expression body definition. Okay. And in the examples that we looked at here, these are expression body definitions. Okay. And it's a shorthand, convenient way of writing properties. It's the way we ultimately tell the compiler to generate code that does something, so we don't have to write it because we're being lazy. Okay. So in this case here, I'd hope somebody might ask the question, because if somebody didn't ask the question, I would have said, do people know what's going on here with this arrow, really? Okay, so good, well done, okay? So it is useful. When you look at that line of code, we need to know what's happening with that line of code. And the lambda operator has two forms. It exists as a lambda operator and as a separator of a member name and a member implementation in an expression body definition. So a variable name and its expression definition. Okay, if you want to think about it like that. They're not variables. When they're inside a class, they're members, okay? But rather than just variables. And there are different member types. You have variables, static members, variable member, all that kind of stuff. Okay? So it's using the second form, okay? So an expression body members are just another set of features that add some syntactic convenience. They look like lambda expressions, but they're not lambda expressions. And I think I do lambda expressions in one of my other short lectures afterwards, so you can see the examples of that, okay? But in this particular case, they're actually set up as an expression body definition. So for example, if you have a property here that's set up like this, a public int my property, and we A hook B and C, and from last year, the hook operator is one of my favorite operators, and also this is an evaluation, and depending on the value of B and C, which gets assigned to A. Okay, so it's fairly straightforward. Then we have something like, which might be a field initializer, which is we use the equal to sign rather than the fat arrow. Okay. And the difference is, and this is the kind of thing could come up on an exam, explain this to me, or give me a piece of code that explains this, right? This first line is essentially the same as writing this, okay? Which is setting a getter property for a getter from my property, okay? And the expression body member will be called every time it's accessed, but this was just a field initializer, and that will only be evaluated once and assigned to that value, and then every time you access that value, you just get the value that was assigned to it initially. Okay? So this is a way of generating some code, shorthand, that allows you to do this. This is explaining this for you. So in lambda expressions then, the lambda operator separates the input parameters on the left side from the body on the right side. Okay, just as an aside. And the fundamental difference is that the lambda expression results in either a delegate instance or an expression tree. And expression body members are just a directive to the compiler to generate a property behind the scenes, so you don't have to write code, because we like to be a bit lazy. Okay? And a delegate, some more advanced C# for you again, a delegate is a type that represents references to methods with a particular parameter list and return type. Okay? Doesn't refer to the actual structure, but to methods that have, no matter what they're called, as long as they have a return type and a parameter list, they're called delegates. And then we'll see a little bit about that a little bit later as well. Okay, again, with some fun stuff. We're getting to the last part where we look at generics. And Microsoft tells us that the use of generic types is there to maximize code reuse, type safety, and performance. And the most common use of generics is to create collection classes, collections of things that we want to work with. Okay? They're called generics. And the .NET class library contains several generic collections in the systems.collections.generic namespace, and they should be used whenever instead of classes. So you don't need to be generating these things yourself. If you have a list of objects, you want to generate lists, don't write a list class. Use the generic list class that's available as part of this. If you want a hash table, use the generic hash table. Do not start doing this yourself, because you'll have to do all the extra work to all the coding, all the error checking, all that stuff. Use the built-in functions. A lot of times students think that they have to do everything. You don't. Reuse what's there in the language. You got to be smarter now. Okay. You can create your own generic interfaces, classes, and methods if you want, and that's kind of nice, because you might have very particular data types that you want to play with and work with. And the information of the types that are used in generic data can be obtained at runtime using reflection. And we'll see a little bit about reflection a bit later. Did you do reflection in Java? Do you know about reflection in Java? No? You ever heard about that? Yeah. It's really, really cool stuff, right? A reflection is a functionality inside the language that allows it to be able to best way to put it, say something about itself, to inspect itself and know how it's structured. Okay? It's like it is reflection. So you can know what kind of types I have. Okay? And Java's amazing for doing this kind of stuff. You can generate objects on the fly that weren't declared in other words, at runtime. You can use reflection to be able to generate objects that have been declared that didn't exist in advance when the program started, because you can reflect on the various types. Okay? Cool stuff. Advanced stuff. I used to teach that in first year when I taught Java many years ago, but because that was the way we used to think about programming at that point. But we don't do that now. It's scary. But generics allow you to write a class or a method that can work with any data type. That's really powerful. That sentence is really powerful. Generics allow you to write a class or method that can work with any data type. You need to think about being smart now when you write your code. Reusing this. Generics, you can write specifications for a class or the method with the substitute type parameters. So look, here we have a generic class called generic. We're not saying what it is, but we know that we have a method here that allows us to add something to the class, to this generic list. We don't have to say what they are, They could be pizzas, could be emoticons, could be shapes. Yeah? So there's ways to do all of this. We don't have to specify in advance what those are at this point. Then we have a class that would test the generic type. So here I'm creating a generic list of numbers, and then I'm adding a number. Okay? Because I'm telling it that the list this is a generic list of ints. Now I'm creating a list of strings. And now I'm going to create a list of my example classes. And my example class was just simple, that did nothing. It could be shapes, for example, that you're using for your assignments. Yeah. And it could be the base. And then you could have a basic shape, and then you could have a rectangular shape and a circular shape that all expend shape. Yeah. And then you can have this list of shapes that you actually manipulate. You can take something in and out of the list. Okay? So we're nearly done. Anyway, Microsoft give a really good linked list demo. I have a link to it here, and I have code which you can take and work. This example is in the code as well. So you can do overloading of methods within your generics. I would advise you to have a look at this slide. It's not a great data storage example. You should use the built-in collections, but this basically shows you how it all works. Okay, so it's worthwhile having a look. Okay. And I've showed you how to look at a swap and a linked list example in my code. And so basically what's happening is that these are collections, and you want to look at collections of data for your assignments from now on. Okay? So arrays of objects, collections of objects, and then bottom line and summary, I guess, is to use the built-in collections generic classes where possible. Don't roll your own. Okay? Please. Okay. And here are some examples: lists, hash tables, stacks, queues, all of the stuff that you know and love from second year. Okay, some advanced features. Thanks for attending. A lot of heavy stuff today. You won't get it all in one go. Come back to it, okay? Think about it and come back to it, and then come back to it again. Thanks again, and good luck with your assignments.